So this video is for writing the names of covalent compounds from the chemical formula and vice versa, as well as determining and explaining whether a compound is ionic or covalent based on the name. And so for writing a covalent compound, we need to make sure we know all of our prefixes. And so there's mono for 1, di for 2, tri for 3, and 4 isn't quad, it's tetra, like the molecular geometry tetrahedral. That's pretty consistent in chemistry. 5 is penta, like pentagon. And 6 is hexa, like hexagon. And just a little note that all these other ones, 2, 3, 4, 5, 6, is used with the first element, except mono is not. And that'll come up in a moment. So here we have nitrogen and 2 oxygen. And so that's going to be nitrogen. Because remember, we don't use that mono on the first element. Di, because there's 2 oxygens, dioxide. N2O, that's dinitrogen. Monoxide. Here we have 2 phosphorus, 5 fluorine. So that's going to be diphosphorus. Pentafluoride. And then chlorine and 3 fluorine. That's just chlorine. Trifluoride. And so working backwards is pretty straightforward since the prefixes directly go with the subscript of the element. So here we have dihydrogen, that's going to be H2. Monoxide, that's 1O. And so that's H2O, that's water. We have phosphorus. There's no prefix there, so that's just going to be 1 phosphorus. Hexachloride, that's chlorine 6. So it's going to be PCl6. And so now knowing all these rules, we'll be able to determine if a compound is ionic or covalent without having to look at the periodic table, just from the different naming conventions there are. So here we have aluminum phosphate. There's no prefixes with either of them, which means that it's going to be ionic. Because prefixes indicate that it's covalent, just as those rules we were just learning a moment ago. So then with phosphorus trichloride, we have that prefix tri, indicating that it's going to be covalent. Dinitrogen pentoxide, the same as before, that there's that di and that pent. So then it's going to be covalent because of that. So then iron 3 sulfide. Remember that we learned that that's what happens when we're working with the D block to indicate the charge of the iron. And so with these Roman numerals indicate that you're bonding with the D block. And the D block is all metals. And so that means that we're going to be having ionic bonding here.